are going to explain about deep HDR reconstruction of dynamic scenes. Introduction. The project addresses the issue of producing high dynamic range HDR photos of dynamic scenes when the brightness range is broad and typical digital cameras cannot catch every detail. Merging many low dynamic range LDR photographs exposed at different levels is the most common way for achieving HDR reconstruction. But this method creates ghosting errors when merging LDR images with object or camera motion. As a result, before merging LDR photos into HDR images, they must be aligned. The project presents a method that combines a standard pipeline and a deep learning algorithm to align the input LDR images to the reference images using an optical flow method based on a deep convolutional network, and then merge the aligned LDR images into HDR images using a deep learning algorithm. Objective. The project's objective is to develop a way for taking high quality HDR photos of dynamic scenes by combining a standard pipeline with a deep learning algorithm. The suggested method uses an optical flow method based on deep convolutional networks to align the input LDR photos to the reference one and then merges the aligned LDR images into HDR images using a powerful network called MergeNet. The suggested method intends to remove alignment artifacts and generate a noticeable HDR impact while avoiding ghost and artifact when recreating saturated areas. The team also intends to generate their own HDR dataset of various dynamic scenes in order to solve the constraints of existing dynamic scene HDR dataset for training deep neural networks. Requirements. The requirements of the project are hardware requirement and software requirement. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following 3 modules. The first module is upload different exposure images. In this module, the user is required to upload a set of images of the same location that have been captured under different exposure settings. Exposure refers to the amount of light that reaches the camera sensor during image capture. By capturing the same scene with multiple exposure settings, the images are likely to have different brightness levels, capturing details in both dark and bright regions of the scene. These images serve as the input to the HDR reconstruction process. Second module is low dynamic range alignment, LDR alignment. Once the set of images with different exposures is uploaded, the low dynamic range LDR alignment algorithm is applied. The purpose of LDR alignment is to align all the input images and create a flow among them so that corresponding pixels in different images are at the same location. This alignment process is crucial for HDR reconstruction as it ensures that the correct information from each exposure setting is used to construct the final HDR image. LDR alignment may involve techniques such as image registration, feature matching, or homography estimation. Third module is HDR merging using deep learning CNN. After LDR alignment, the next step is HDR merging using a convolutional neural network CNN. The CNN plays a critical role in the HDR reconstruction process. It takes the aligned LDR images as input and processes them through multiple layers of convolutional and activation functions. The CNN learns to combine information from different exposures and generate a high dynamic range HDR image that represents a wide range of intensities, capturing details from both the darkest and brightest regions of the scene. The CNN leverages the power of deep learning to discover complex patterns and relationships within the aligned LDR images. Through the training process, the CNN learns to analyze and merge the information from different exposures, ultimately producing a new HDR image with improved dynamic range and enhanced image quality. The HDR merging using deep learning CNN module involves training the CNN on large dataset of aligned LDR images with ground truth HDR images. The CNN learns to minimize the difference between its predicted HDR images and the ground truth HDR images during the training process. Once the CNN is trained, it can be applied to new sets of aligned LDR images to reconstruct HDR images of dynamic scenes with varying lighting conditions. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the backup folder in which we have CNN HDR test files which are used in the main code. And this is the helper folder in which we have arcs, custom freeze graph, loader, optimized for inference, TF graph utility. These all are Python files which we have used in the main code for the execution of the project. And this is the images folder, in which we have the sample images which we have used during the execution of the project. This is the model folder. This model file contains the algorithm information which will be loaded into the runtime during the execution of the project. And this is the main code file. This is mergenet main code file. This is run.batch file. Instead of executing our project in the command line interface, we have created Windows batch file to execute the project. Double click on run.batch file. A graphical user interface will pop up. This is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on Upload different exposure images. Select sample1 folder. So here we will have the different images. In above screen, we can see one image is taken in dark light and one is in normal light and one brightest light. And we can get clear LDR image from above 3 images by clicking on low dynamic range alignment. In above screen, first 3 images are the input image and the fourth one is the LDR image, which is looking little clear compared to 3 input images. Now to get HDR image, click on HDR merging using deep learning CNN. In above screen, first 3 images are the input image and the fourth one is the CNN applied HDR image, and in that image we can see backside clothes hanging on rope with more clear compared to other 3 images. So that is why it is a HDR image in which we have the complete quality. Now click on exit the GUI, and the final conclusion of the project is that the proposed method combining traditional pipeline and deep learning algorithm produces high quality HDR images of dynamic scenes and outperforms the state-of-the-art approaches on challenging dynamic scenes. The project proposes a novel pipeline to address the challenging problem of HDR reconstruction of dynamic scenes and demonstrates that the problem of HDR reconstruction can be formulated as a pipeline of alignment and merging and tackled by a combination of optical flow and deep learning. The project also reports the advantages and disadvantages of the proposed improvements by executing extensive experiments. Although the proposed method performs well, it is still a long way far from being widely put into use in our smartphones due to the limits of speed and robustness. The project suggests integrating the optical flow network and HDR merging network into one more powerful network to speed up in the future.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.